Good afternoon. Here is a question from Resnick Halliday's 10th edition. The question reads, an airplane is flying in a horizontal circle at a speed of 480 km per hour. If its wings are tilted at angle 40 degrees to the horizontal, what is the radius of the circle in which the plane is flying? Assume that the required force is provided entirely by an aerodynamic lift that is perpendicular to the wing surface. To solve this question, first we need to make a free body diagram. Let me draw the plane. So plane looks like this, and these are its wings. The wings are tilted at an angle of 40 degree with the horizontal. This is 40 degree. Its weight acts perpendicular like this. This is mg. That's the weight, the force with which the earth attracts the plane. Now this is 90 degree, so this angle will be 50 degree. Now the components of mg along the wing is mg cos 50. This is mg cos 50. mg cos 50. Now the other component of mg, that is perpendicular, that is mg sin 50. And the centripetal force acting towards the center of the circle is mv square by r. Now the angle this force makes with the wing is 40 degree, because alternate interior angles 40 degree. This is 40, so this has to be 40. Now the component of mv square along the wing, I will represent it using a green color, is mv square by r cos 40. Now there is one more component of mv square, that is the sine component, that is perpendicular component. This will act upwards, and this is given by mv square by r sine 40. And there is one upward thrust from the winds, that is Fn. Now we get two equations. The one is Fn plus mv square by r sine 40 should be equal to mg sine 50. Now this is not a useful equation for us, because we don't know the aerodynamic lift that it is getting in. But these forces will be equal because the plane does not have any vertical motion. So we have equated this. The second equation that we get is from the fact that centripetal force will be provided by mg cos 50 to move in this horizontal circle. So mg cos 50 is equal to mv square by r cos 40. Now this equation is very useful. We can cancel mass, and then we get r equal to v square by g cos 40 by cos 50. Now cos 40 can be rewritten as sin 50, then sin 50 by cos 50 becomes tan 50. So the r is equal to v square by g tan 50. Now the value of tan 50 is 1.19, and v is given as 480 km per hour, which is nothing but 133.3 633 meter per second. So if you put these values, you'll get the value of R, and R is simply equal to 2158.622